Okay, in this video we're going to look at solving a word problem using a 3x3 system of linear equations, problem type 1. I highly recommend that what you do for this video is make sure you're using the packet of notes that I passed out for chapter 3. This problem is the bottom of page 2, so that you can, you don't have to write down all this information, at least not the original word problem, and you can just write down the work and have an easier time of it. So in this problem, we have Martina, Dale, and Ahmad serving a total of 65 orders Monday at the school cafeteria. Martina served 10 more orders than Dale, and Ahmad served 3 times as many orders as Martina. How many orders did they each serve? So to begin with, in math, in a word problem, usually the last sentence or question gives you kind of the topic, and it's a great place to start because you need to know what it is that you're trying to figure out in order to set the thing up. So we want to know how many orders they each served, meaning Martina, how many orders did she serve? So since I don't know what that is, I'm going to let the variable m, or the letter m, represent or be equal to the number. I'm going to use the pound symbol, the number of orders Martina had made, or just made. I'm going to let the letter D be the number of orders Dale made. And I'm going to let A be the number of orders Ahmed made. So we have the 3 different letters. Now we're supposed to set up 3 different equations. That's why it's called a 3x3 system. 3 variables, right, and 3 equations. Now, if we had fewer equations than variables, that would be a problem. Meaning, if I had like 3 variables and only 1 equation or 2 equations, we wouldn't be able to solve it. But because we have 3 variables and 3 different equations, we should be able to solve this thing. Let's see if we can set up a couple. First off, Martina, Dale, and Ahmad served a total of 65 orders, meaning if I were to add together the number of orders from Martina to the numbers of orders from Dale and from Ahmad, that would be a grand total of 65. That's one equation. I also am told that Martina served 10 more orders than Dale. So if Martina served 10 more orders than Dale, I know that if I were to take, make an equation here. I know that these aren't equal, but that Martina served more than Dale, meaning I'd need to add on 10 more orders to Dale's number to get Martina's, right? Because Martina served 10 more than Dale. So if like Dale served 5, then add 10, that would be Martina's 15, or something like that. So that looks good to me. And then the last, or second to last sentence here, Ahmad, served 3 times as many orders as Martina. So Ahmad should be equal to 3 times the number of orders Martina made, which also should make sense. If Martina served 10 orders, Ahmad would be 3 times that amount, right? 30. That would be good. So you could see I have 3 equations. We have 3 unknowns. It's kind of a mess until you just start substituting some things in. So there's a few different ways to attack this, but I think as long as you're trying to substitute some values in, you're going to hopefully be able to narrow it down to 1 equation with 1 unknown. So the goal is ultimately to get 1 equation with 1 variable. That's what we want. That's what we can solve. So right now we don't have that. But what I'm going to do is, let's start off by saying, all right, in this equation, I see m plus d plus a is 65, but I know m is the same as d plus 10. It might be tempting to just say, all right, let's substitute in d plus 10 in the place of m and rewrite what we have, and that would be fine. There's various other things we could do, but let's start with that because I have a feeling most of you would probably do that. So instead of m, I can substitute in d plus 10 plus d plus a is equal to 65. Now simplifying this a little bit, d plus d would be 2d's plus 10 plus A equals 65. So all I did was kind of add like terms on that step to kind of make it a little less sloppy. And you might even subtract 10 to make it a little bit nicer looking as well. So I have 2D plus A equal 55. Now the problem is I still have D and A in here, and I need to get just one variable. And you might say, all right, well, how about, A is the same as 3M. Okay, well, let's do that. Let's replace A with 3M. So now I have 2D plus, instead of A, I'm substituting in 3M, and that's equal to, 55. Let's scratch that out. That's equal to 55. So now, although we have still two different variables, I'm a step closer because M is the same as D plus 10. And if I replace the M here with the D plus 10, would you agree that all of this then would be in terms of just D? That we'd only have the letter D, which is great. We can solve it. So let's do that. Let's rewrite 2D plus. Now, it's going to be 3 times the M value, so it's going to be 3 times the M value, which is D plus 10 from our second equation that we originally wrote, should be equal to 55. So now we're in business. One equation with one unknown. I can distribute to get 2D plus 3D plus 30 equal to 55. Well, 2Ds and 3Ds make 5D plus 30 equal to 55. If you subtract 30 from both sides, let's go sneak this up here, I get 5D equals 55 minus 30 would be 25. Dividing by 5 would get D is 5. What we just figured out is that Dale had made 5 orders. All right, and then from here, we can probably easily get the rest of them. If I know Dale is 5, if I just go to my second equation here, Martina is simply Dale's order plus 10. So Martina is 5 plus 10, she would be 15. And then Ahmed, we know over here, is 3 times the number of Martina's orders. So 3 times 15 is 45, and that would be our total. And we could even double check that if we add them all together, we get 65. 5 plus 15 is 20, and 20 plus 45, that is a grand total of the 65. So I'm feeling pretty confident that we knocked this one out. Hopefully this helps you, and thank you for watching.